In this video, I will be going over the relative Maxwell's equation in vacuum. So what that means, what that means is that we need to consider the space-time split of F. So we have space-time split of the bivector. And that space-time split looks like this. So F is equal to F gamma naught squared, which is equal to F dot gamma naught plus F wedge gamma naught, where these then become the E plus BI. Where these right here are bivectors in the spacetime algebra, but they map to vectors in the APS. So maps to a biparavector in the APS. So it's just the electromagnet. It would be the electromagnetic field, though this is actually something you can do for any bivector. But in this case, yes, we are considering Maxwell's equation stuff, so it is an electromagnetic field. So then if we consider the gradient of this, so we take the 4 gradient of this bivector, then it's the same as having gamma naught, partial naught, plus the 3 gradient times E plus BI, where this is just the definition of the split, space-time split for the 4 gradient, where we covered that in the gradients video. Then multiply this out. I'm going to keep the leftmost gamma naught in the equation. Get partial naught E plus partial naught BI plus 3 gradient E plus 3 gradient BI. So we have this. Which is then equal to gamma naught, and we can expand out these right here. And the way that we're going to expand that out is by using the identity. So we're going to use this identity that the 3 gradient of some bivector A is equal to the 3 gradient dot A plus the curl, the 3 gradient cross AI. So that's the definition that we're using there. So then continuing on from that, we can expand out. We can expand out these terms. So first I'll copy these, then plus, going to have divergence of E plus the curl of E I plus the divergence of BI plus the curl of B. Then you have 2 i's, right? Because there's an I in this equation too, so you have I squared. You come down, And now I'm going to regroup everything that has a pseudoscalar in to be in a separate term. So you'll have everything without the pseudoscalar and everything with the pseudoscalar. So that becomes partial E plus divergence of E minus the curl of B, then plus gamma naught partial of B plus the divergence of B, and then plus the curl of E. And then, of course, the pseudoscalar right there. So then you get these two terms. And when these are equal to 0, so if you have the gradient of f equal to 0, which is what a Maxwell's equations are in vacuum, then you can take, then you have that this above equation here is equal to 0, which means that you can now set all of these things independently equal to 0, all of the terms that will give similar grades. So you can have, you'll have that the divergence of E, you'll have that this divergence of E here will also be equal to 0. You'll have that the divergence of B is equal to 0. And you'll also have that the, or like you'll have the change in time of E is equal to the negative curl of B. So I'll actually write that like this. So curl of B is equal to negative, or it would be positive on this side. So like this. And likewise, you'll have from over here, these two, you'll have the curl of E equal to negative change in time of B. And these are just Maxwell's equations in the absence of any charges, so they're in a vacuum. And of course, it's in its relative form from a space-time split of the bivector and the gradient.